Okay, so I'm going to try to do a quick video here kind of explaining 6.3 and, I'm sorry, yeah, 6.3 and 6.5. So 6.3, I don't really have you do any homework problems because the math is a little intense at times, and it really doesn't get to the point of it. I think simulation is a better way to do this. So if you go to the course page and you download section 6.3 Simulation Excel, I've already got it all built for you, right? And so I got a chi-square one, which you don't really have to worry about. The dice roll one, I think, is a better one for us to kind of look at. So I'm on the dice roll tab. So what the simulation does, it simulates 148 different people rolling the dice. And if we scroll down here, each person rolls the dice, I want to say, 1,000 times. Yes, 1,000 times. So it is simulating 148 people rolling the dice 1,000 times and writing their results down. Right? That's why simulation is so good. I can do something that a person can do with a computer and save myself time and money. Right? So basically, we roll a dice, and it's a random number between 1 and 6. Every time you roll a dice, each side is equally likely. So therefore, each number is random. So Excel has this function called ranBetween, where it randomly picks a number between 1 and 6. All right. So if I find the average of this column, that is the average of all the numbers. So I sum them up and divide by how many I have. Percent of odd, right? If you think you roll a dice, 1 through 6, 1, 3, and 5 are the odd numbers, 2, 4, and 6 are the even, so you have a 50% chance of getting an odd number. And you can see through the simulation, here, each one is about 50%. Right? And if you actually go through back to chapter 5 and you count the probabilities by building a probability distribution function over a dice roll, you'll see the answer is 3.5 for the mean. Right? So 6.3 talks about a comparison between a population parameter and a sample statistic being unbiased. All right? And I put a little table and a little bit in the handout as a visual, and here's kind of the math behind it. And again, 6.3 is mainly to get you to hit the I believe button. So when we get into 6.4 for central limit theorem and things we're doing, you understand why we're allowed to do what we're doing, not so much that you have to prove it. All right, this kind of proves it. So here's my simulation. So if you're on a PC, and if you want to open up the Excel, you can see it kind of do this. If you hit F9, function 9, all these numbers will change. And every time you hit F9 in Excel, it reruns the simulation. You can see all these numbers will kind of bounce around. If you are on a Mac or an Apple computer, you hit Command and the plus minus key next to the delete key, and the numbers will change, right? So I can do it so you can kind of see. I'll hit it. I'm on a Mac. And it's probably going to be a little slow because everything is. I'll do it again to see if it actually change here. Come on. I don't know why it's not changing. My computer has not been like in Excel lately. It's running extremely slow right now. Come on. Let's go back to the top. Well, on your computer, because hopefully we're running my Mac's getting kind of old, Command, plus minus, or F9 will make them rerun. I don't want this to freeze up, then I have to redo the video, so we're just going to leave it. Another issue with my video right now, as you can see, my Excel's moving slow. If I scroll all the way to the right, my 3 charts aren't here. Right, because I have an older Mac and an older version of Excel, and I won't rebuild it. But on your computer, it should work. You'll see 3 histograms. Right, the first one here is a calculation of the dice roll, and every number is equally likely, so the bars will bounce between 1 and 6. Then I have one for the mean and one for the standard deviation. Variance. And again, I'd highly encourage you to open up your Excel and hit F9 or Command plus, and you'll see the graphs change as the numbers change. Right? This shows you basically that these are good estimators, right? Because we already said percent of odd should be 50%, and 3.5 should be the actual mean. And you can see these numbers are close because they are good biased and unbiased estimators of the data here. That's really all 6.3 shows. So play around with the simulation. Again, it's just to get you to understand why we can do what we're doing later in the chapters. You won't have to do any of these calculations for yourself. There won't be any on the quizzes or tests or homeworks. It's just understanding why we can do what we can do. The big takeaway from 6.3 is these are unbiased estimators. That little table that's in the announcement is key. All right, so the last thing, 6.5, is assess a normality, right? We want to make sure our data is bell curved, because if it's bell-shaped, then we can apply the statistical analysis that we're learning. And we've already learned two different ways to do that. We can build a histogram, right? And if our histogram is bell curved, then our data is normally distributed. Or we can build a box plot. Now, a box plot doesn't guarantee your data is normally distributed, but it will tell you if your data is symmetric or skewed. Well, if your data is skewed, then it is not normally distributed. If it is symmetric, you still need to verify that it is normal, because the other distribution, as the book talks about, is also the uniform, which is also symmetric. So a box plot can tell you if something's symmetric or not, but it can't tell you if it's normal. Histogram can tell you if it's normal, but again, it's very easy to manipulate a histogram based on your class width or your bin size. So the best thing to do is called a normal quantile plot in this book, or sometimes you'll see it's called a QQ plot, which I call it, is a quartile plot. And this is how you build it. So on page 278, it goes into how you build it, right? So first, I took all my dice rolls, right? So here are my dice rolls from the simulation. I pasted them here. And if I want to sort something, I just highlight the data. And you can see there's 1,000. There we go. And then I can click data, and then I can click sort. So always expand. That way if you have other rows, you can move it. All right? So it mattered me because of these things. But you can see my data is sorted. It's got the smallest number that comes down. So that's step one, right? Page 278 says first sort your data. Then it says with a sample size of n, each value represents 1 over n of the sample. Basically, what you want to do here is you want to make odd numbers, right? So step 2 is just make this a 1. Oh, come on, Excel. Don't do this to me. There we go. 3. My computer is not probably liking I hit those command enters and it's trying to figure out where it's going. Sorry. I probably shouldn't hit them. I really need to update my computer from home. 5. All right, so we'll have to get a couple in here. If I highlight, you see I got this big plus. I bring it down here. It turns to on this my PC turns to a black plus. On your Windows machine, it'll turn from big to small. And I can just drag this down and see Excel sees that I'm creating odd numbers. So I'm just going to create odd numbers all the way down. So I have a row of all odd numbers. Hopefully, my Excel does not freeze on me. There it goes. So that's step 1, sort the data. Step 2, create a column of odd numbers. So step 3 says to use this formula, b divided by 2n, right? So b is the odd number. So if I hit equals, and I click on that cell, and I'm going to divide by 2, put them in parentheses, because if not, it's going to mess up my order operations, 2 times n, which in this case is 148, right? So I'm just going to put 148 in there. You could just click on that cell and lock it by putting the money sign in, but I'm just going to type 148 in. And then hit enter. And while this is doing this thing, there we go. Now, once I have that, I click back on that cell, and I do the same thing. I go to the right. Now, because I have a pattern going here, I can just double click. Hopefully, it'll work on my computer. Yours, it will. There it goes. And it creates the formula all the way down for each of the columns. Takes that number, divides by 2 times 148. So I have created b divided by 2n. Now step 3 is I do, make sure this is, use the standard normal distribution calculator to find the z-score that corresponds to this number, right? So to do that, make sure I am doing this right. Yeah. yes. I just in here to equals norms inverse with the S, because I want z-score. This is a probability, right? I want the z-score, so I want the event, so I'm going backwards. So just like we learned before in chapter, earlier in the chapter, I will click on this cell, enter. God, my Excel is definitely not going well tonight. And I do the double click thing. And you'll do a smaller version of this as one of your homework assignments. So now I want to graph this thing, right? So I'm going to highlight this column. Stop. The good news, if I was on a PC, I haven't figured out how to do it on a Mac yet, but on a PC, if you click on the first cell and you hit Command-Shift-4, it'll highlight the whole column. I have not figured out how to do it on a Mac yet. The problem is Excel is still a Microsoft Office software, and so it doesn't have all the cool gadgets that you get on Windows. So I'm going to copy that cell and paste it over here under step 4. And then I'm going to take step 3, copy that one as well. Command C. And then I come over here and paste the Command B. And the reason I'm doing this is because Excel won't paste it as values. I want you to paste it as values, not a number. There we go. So I repasted those as values. The reason it gave me an error because it looked at an empty cell to find norms inverse. Right? So now, if I go to, as soon as my thing starts to work again, charts, I want to put in a scatter plot. So I'm going to highlight these two columns. And I want to insert a scatter plot. And what you want your scatter plot to look like, you don't want to have more than 2 outliers according to the book. We have 3, but again, we're okay. This is just the book's guidelines. The big key takeaway from this is this should look like a line, which it looks fairly good, right? So therefore, our data is normally distributed. The mean of means, which is going to be 6.4, the central limit theorem is based off this fact. We've also just shown this is basically 6.4. Central limit theorem says if we take a bunch of sample means and we put them together, it should be normally distributed. Well, that's what we did. We just took 140 average dice rolls and put them together, so it should be normally distributed of a sample mean, right? And then what it doesn't like is, remember, 2.5 is where we want to be, and we have a couple that are a little more than 2.7 away. And you can see 3.5 is our average. This one that's away is 3.6. You know, so that's not that far away if you think about the way we do averages. But because everything else is so close because of the central limit theorem, 3.6 is beyond the 2 standard deviation thing. That's why these kind of look like outliers, right? But how do you assess a normal probability? It has to not have a lot of outliers, and it should form a good straight line, which it does in this case. You will have some homework problems that it does not. But this just proved our data is normally distributed, which we should know. That's why I do the dice roll, because we've done some things with dice prior, especially if you're taking this with me in the classroom, which some of you are not as my online students. But if you watch this video in the classroom, we've done a lot with dice rolls in the classroom, so you should really see how all these kind of concepts come together. This video is very just kind of understanding the theory of Chapter 6. That's the big key takeaways from this video. All right, email me as always if you have any questions, and enjoy Chapter 6.